Welcome back. So far, our functions are capable of outputting a value using return, but they can't accept any inputs. And all the built-in functions, or almost all of them that we've seen, things like print, that accepts an input. Same thing with a list.append. We need to tell it what to append. Those inputs are really important because they affect how the function works. So in this video, we're going to see how to alter our functions to accept inputs. And fortunately, it's really easy. So we have this square function that always squares 7. But let's alter it so that we can do things like square 4 or square 8. And it should return, in this case of squaring 4, it should return 16. And in squaring 8, 8 times 8 is 64, so it should return 64. So to do this, I'm going to remove, this isn't a new file, I've retained the original file if you want to reference it, but this one I'm calling square.py, and let's just start over. And what I'm going to do is define a function this time with def, and I'll just call it square. And we can start just like this, but we need to tell this function to accept a parameter. And we can give it any name we want. We could call it x, we could call it num, number, we could even call it string, even though it won't be a string. It's totally up to us, just like naming a variable. But we want to abide by the same rules that we follow when naming variables. So we don't want to, put it in all caps or something, or have it start with a number, that sort of thing. So let's just call this num. We want to give it a common sense name. Num makes sense. And all we will do in here is return num, either num times num or num to the second power, just like that. And we'll save. And now everything should work. If we square 4 and square 8, everything should be good. The only thing is we are not printing those values out. We're just returning them, but they're not being captured in a variable. So let's just try printing them both, just like this. Okay, so we've defined our square function. It takes a single parameter, totally up to us to name this whatever we want. But just by adding this here, it tells Python, hey, this function called square is now going to accept a single parameter. It's expecting just one thing, so we'll see in a bit how we can have multiple things. And we're just going to call it num. And it's just a way of saying whatever the user or the code passes in when square is executed, just give it the temporary name of num. So let's run it. So this is going to be Python 3 square.py. And we get 16 and 64. So we successfully have written a function that accepts an input and spits out a version of that input. This time it's squared. Here's another example. We have this silly sing happy birthday function that always sings the exact same song, but in real life, the song is happy birthday to you, happy birthday to you, happy birthday, dear somebody. How about happy birthday, dear Charlie, happy birthday to you. So let's alter that so that it accepts a name, and we could call it person, call it name, and then all that we want to alter is right here, print happy birthday, dear, and in here, we'll stick the name. And we could make that an F string. Or we could use concatenation, but this is a nicer way of doing it. And now, when we call sing happy birthday, if I just left it like this, I'll just do it one time, and I run this, what do you think we'll see? So let's try it. Python 3, and I called this one sing.py. And what do you know? Missing one required positional argument, name. So there's an error here, because we didn't pass in the parameter. Technically, it's called an argument in this case. We'll go over that distinction in just a moment. But we didn't pass something in, and so it's unhappy. So we need to do that. So let's pass in Rashida and try it now. And there we go. Happy birthday to you, blah, blah, blah. Happy birthday, dear Rashida. So we now can alter the behavior of this. Let's do another one with Nicholas and Rashida this time. And we get both versions of the song. Okay. So we've seen how to do this with a single parameter. If we take a look at the slides, there's an example now that has 2 parameters. So this function is called add. And I've just called the different parameters A and B. We separate them with commas. So we can have as many as we'd like, but they need to be separated with commas. Call them whatever you want. And in this case, all we do is return the sum of A and B, A plus B. Or here's another example. This one is called multiply. And we're calling the first parameter first and the second one second. And then we return first times second. And to call it, all we have to do is pass in two values separated by a comma. And whatever the first one passed in is will be associated with first. Whatever the second one will be called second. Now it's important to know that these names, these parameters, only exist inside of the function. So if down here I tried to do a print name, or even afterwards, like in this example, let's just do Nicholas. We sing happy birthday Nicholas. Inside of this function, name refers to Nicholas when we pass it in, but outside, it doesn't exist at all. And we get an error, name is not defined. So that's just important to know. This is not a variable declaration. A parameter is something different. Let's quickly talk about naming our parameters. So here's an example that just prints out or returns an F string that just takes a first name and a last name, and it puts them together with a space in the middle instead of a string that says your full name is, blank blank. This is a better example, a better way of writing this function. All that's changed are the parameter names. So rather than string 1 and string 2, it makes a lot more sense. It makes your code much easier to understand to have parameters with names that actually make sense, that are semantic. So in this case, first name and last name, that's what these are. Technically, string 1 and string 2 is totally fine. We could also have gone with banana and cucumber, and it wouldn't change the behavior of the function. But this is just about making it legible, making it make sense. So the next thing, this is kind of a nuanced, weird topic, not really important to actually writing functions with parameters, but important when discussing them. There's a difference between parameters and arguments. You might hear them used interchangeably. It's a very easy thing to do, but they are different. Parameters refer to the variable in a method definition. So actually when we define the function, this is a parameter right here. But when we actually call the function or method, the arguments are the data we pass in to the parameters. So a parameter is in the declaration, and the argument is what is actually called in the execution. So in this example, name is the parameter. It's what is inside the function definition. Nicholas is the argument we pass in. A lot of times you might hear someone say something like, let's define a function with two arguments, name1 and name2. Technically, these are two parameters. And down here, if we passed in two things, we would say, let's call sing happy birthday with two arguments, Nicholas and Julia. So a minor distinction, as in the grand scheme of things, it's not going to change the behavior of your code, but it's important to know that there is a difference when you're discussing that, or when you hear me say argument versus parameter. So one last example, I will make a file called divide.py, and I'll declare a function called divide. And it will just take two numbers, num1 and num2. I know there's a name for, when we have like 1 divided by 3, one of these is called the operand or something. I don't remember. I'm just going to call them num1 and num2. It would be better to get the official names though. But I just want to show that the order does matter. So if I just return num1 divided by num2, and let's do a print divide, and let's pass in 1, 5, and then do the same thing, 5, 2. Actually, let's do 2, 5, and then 5, 2. The order does matter. Whatever comes in first is going to be referred to as num1. Whatever is second is num2. So if we look at what we get here, let's run this, Python 3 divide. We get 0.4 and then 2.5. So it does 2 divided by 5 first, and then it does 5 divided by 2. So all that I want to show is the order matters. If we just switch these, it would achieve the opposite. Num2 and num1, these would be switched in the results. And this first one would divide 5 by 2. Okay, I'll leave it off there. Next, we have a quick little exercise.